get the canvas? I got here a bit late.
Yeah, to get the this is very important, and I'm glad you mentioned it. Okay, everything comes from this website, samsclass.info. That's the most important thing. In fact, I'll write it on the board. That's the only thing you really need to know. Not a great pen, but I think it'll do. You start there, then you click the name of your class, which is down at, this is this one here, ComSC 132. And then you get here, and if you go down to the quizzes, you'll find how to get to my Canvas server. And the only thing on the Canvas server is the quizzes. All the projects are on this page.
So I hit enroll here?
You can't what?
Do I hit enroll here or view course?
Either one. They'll lead you to the same place right now. We go to click one of them and create an account using an email of your choice, and then you enroll in the course with the enroll link. And then you'll see the quizzes and other things on the Canvas there. Although it's pretty much nothing but quizzes. Good? And so, what I wanted to do is show you binary games. This is in a lot of my classes. A lot of my students don't know binary, and you really need to know binary to get anywhere in computing. So, yeah, I encourage people to learn it. And I found the best way to teach it is a little bit at a time. I used to teach Cisco, which has got a lot of binary in it for subnetting, and the official way to teach it is completely wrong. They start from not even knowing binary all the way up to subnetting one lesson, and this is a fundamental problem with the way Americans teach math. I've given talks to high school teachers and everybody. I'm really upset because math is wonderful and students just get abused in the American educational system. And most of them around 4th grade think math is hard and they're stupid because they've been abused. You teach math the wrong way, everybody feels stupid. The thing about math is once you understand it, it's easy. But when you don't know it, it's hard. So a teacher says, flip, 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 it's easy. What are you, stupid? This is no good for anybody. It's hard when you start, but if you can count on your fingers, you can do math. Because it's all that simple, but you have to learn each step before you go to the next step. So let's start with simple math, which is nibbles. Nibbles are, let's see, good, that's showing all right. All right, so in base 10, which is what we all use all the time, if I write 147, you know the number on the right is the number of ones, the 4 is the number of tens, and the 1 is the number of hundreds. And you may have forgotten, but I remember around 2nd grade finding this very strange and mysterious when they explained it to me and feeling like that was hard to understand. You might have got used to it by now, but at first it's kind of a weird way to record numbers. And it's a new system. The Romans used a different system. This is the Arabic system, which turns out to be very handy, but it's harder to learn. So this is the ones place, that's the tens, and that's the hundreds place. But computers use base 2. So all they have is 0 and 1, nothing else. So 1, 1 is 1 times 2 plus 1, which is 3. And that means instead of having ones, tens, and hundreds, you have ones, twos, and 4s. So this is 5. You have a 4, you have 0 2s, and 1 1. So 4 plus 1 is 5. And so with 3 binary bits, you can count from 0 to 7, and that's it. 0 is 0, of course, 1 is 1, 2 is 1 0, 3 is 1 1, 4 is 1 0 0, because it's a 4, no 2, and no 1. And this is a 4 and a 2 and a 1, that's 7. It's the largest possible number you can get with 3 bits. And this gets you to the system called octal, which was used a really long time ago in computing and is almost completely extinct. You won't see it anywhere except Unix permissions anymore. But what we're all using is this system with nibbles and bytes. And the word nibble is not commonly used, but you'll see it's real useful when we get to hex. So you have 4 bits, and all you have is 1s, 2s, 4s, and 8s. So this is 9. 1 8 plus a 1 and nothing else. And there are only 16 possible nibbles, and there they are. You can count from 0 to 15, and there are a lot of things. You get used to this. If you want to get good at this, you learn some mnemonics. Here's a good one. Even numbers in base 10 are also even in base 2. All the odd numbers end with 1. All the even numbers end with 0. 10 10 is 10. It's 8 plus 2, no 4s, no 1s. The largest number is 15, all 1s, because it's 8 plus 4 plus 2 plus 1. And you can do it by adding the numbers, but it works out to be better to learn your nibbles. Anyway, so that's just all we're going to do in the way of binary today. I just want to show you how you get credit for this. So once you've got it, go here and do the project where all you have to do is answer some questions here. And I modeled this after the Khan Academy, so you have to get like 5 or 10 of these in a row right to win. So 1001, what's that in decimal? What's that? What'd you say? 5? It's not 5. Any others? Yeah. It's not, right? Because this is the number of 1s, this is 2s, this is 4s, and that's 8s. So it's 8 plus 1. Okay? How about this one? Move that over a little. That's 4, right? Because it's 1s, 2s, that's the number of 4s. It's a 4 and nothing else. And how about that one?
8.
That's 8, right. So do this, and after you get a certain number correct, you'll get a flag here. And then you put that in the scoreboard. And if you haven't found that yet, although most of you have, the scoreboard is just right here. So this project is called H101. So after you get the flag, you put it here. You select H101 up here, which is there, and putting your name in the flag. That's how you get your points. So that's all I wanted to show you today. I find doing one of these per class is the right way to do it. And it's all going to stay as simple as that if you do it one step at a time. Anyway, so that's the first thing, is binary games. And I'm going to stop this recording.